Welcome to this introduction of CyberSense from Index Engines. CyberSense is an analytics solution that utilizes machine learning as well as forensic tools to detect and recover from cyber attacks. To position CyberSense, you have to understand where it fits within the data center. There's a number of different ransomware and cyber protection solutions that exist on the market today. Most of these are real-time ransomware detection tools. They are critical to use. They are obviously have some impact and some effectiveness, but they are not 100%. CyberSense adds another layer of protection on top of these tools. The first set of tools is something like McAfee, the real-time malware protection. Uses signatures to really look at executables, create blacklists, whitelists to monitor activity and real-time scans. They work. They've been in effect for years, not 100%. There's also real-time behavioral analytics, something like a Varonis, that monitors unusual user activity. They work. They don't work 100%. So there's slow attacks that don't set off these behavioral alarms. There's attacks that change data without changing the metadata under the covers. There's attack that totally bypass the file system and write directly to disk. The behavioral analytics don't really catch those. So if they worked, if they were 100% effective, we wouldn't be having this conversation, but we know that's not true. They do have significant effectiveness. They should be utilized in the data center. But what we're talking about today with CyberSense adds a layer of protection on top of this. Assuming that they do fail, CyberSense allows you to really understand the data that has been corrupted. So if you look at the attack vectors, they're very common. There's really three main ways they modify the data. And again, we're talking about CyberSense. It's very data specific. It looks at unusual changes of data. The three key ways, or the three ways they modify data, is encryption. That's one of the most common ones. Is they encrypt files, they encrypt pages in a database. Another approach is corrupting key data structures. Another is deleting important data. With those three attack vectors, with CyberSense, the ability to detect that this is happening, to look at how data continuously changes and detect that it's happening within your data, within one backup cycle. So yesterday, everything looked okay. Today, it looks like we have problems. So within one typical backup cycle, you can recover the corrupted data just like any other disaster by using your data protection software. So the fact that you're monitoring it continuously to see how data changes, when you do see this data change occur, specifically related to a cyber attack or a ransomware attack, you can recover the last good copy, just like you would with any disaster recovery approach. So let's talk about CyberSense. CyberSense supports a number of different data types on structured files. So your key documents like contracts, agreements, intellectual property, financial documents, those are types of files that should be monitored for cyber attacks. Also databases. So CyberSense supports Oracle DB2 SQL databases to protect business critical applications. The unique aspect of CyberSense is that it supports backup data. So Index Engines has a technology that really gets inside backup images like NetBackup, TSM, Commvault, Networker, Avamar, and support the contents in there. So CyberSense can run in a number of different formats, but a number of different environments. But the important point that you need to understand about Index Engines is that CyberSense is built on the Index Engines platform that can index both primary data sources, network data sources, as well as backup data sources without the need for the original backup software. So CyberSense can be implemented in the data center in a number of different ways. CyberSense can be implemented across primary data sources, so selective file shares, production backup data, so disk-based backup environments, or a vault configuration. This is a typical Dell EMC deployment of their cyber recovery solution, which is a vault-based isolated environment to protect the critical crown jewel data. So CyberSense analytics can be set up to have scheduled scans across any one of these environments, or a combination of the two. So you may want to scan some data on primary storage, but not put that data in the vault. That's a typical deployment. So each scan of CyberSense is an observation. So the beauty of CyberSense is it's all automated. CyberSense uses machine learning to be able to create observations of each scan. So whether it's a scan of primary storage, a scan of your production backup, a scan of data in the vault, it creates statistics associated with these observations and scans that detect signs of an attack. So how does that work? Let's get into that. The workflow, as I mentioned, the first step is the scan. Again, we can point to network file systems or backup images, either way, or a combination of the two. After the scan, a series of analytics are generated. In the analytics, basically there's about 40 or more statistics that are generated with each observation. So a day one observation is your baseline. Look at the data. Day two observation is a comparison of the statistics from day 1, day 3, and 4, and 5, and so on and so on. So it's comparing statistics with each observation of the data. The statistics are a set of analytics that look at things like file entropy. So entropy is basically the random disorder of a file or a page of a database. So it could be either a file or a page of a database. So for example, if a Word doc becomes encrypted, which is a common attack vector, as we mentioned, the entropy score, which is a score from 0 to 100, increases dramatically. So yesterday, the Word doc could have an entropy score of 10. Tomorrow, it could have an entropy score of 90. So there could be some modification of the file that would result in that, pretty rare. But typically that results that the file was fully or partially encrypted. Or it can be done with a page of a database. If the entropy score of the page of the database increases significantly, typically it would result in be caused by something like encryption. So entropy score, there's a similarity score from 0 to 100 when files suddenly become very dissimilar. Looking at file corruption, so when a malware strips out content and makes it a 0-byte character file, for example, that becomes a corrupt file, that would be flagged. Mass deletions, mass creations, and many more. One of them is file type mismatch. So in scanning the data is defined by reading the header. So by scanning a Word doc, reading the header of the Word doc defines it as a .doc file. If the extension doesn't match that, then that's a file type mismatch. So common malware would strip out the extension and make it .loki, for example. So 40 plus statistics that are generated based on scanning of the data. The statistics have value, however, the machine learning at this point is applied to those statistics. So we've trained CyberSense with all the common malware that exists. We continue to do that. The beauty of that is that most of the attack vectors of what they do to the data, the corruption of the data hasn't changed or doesn't typically change. It's encryption, it's data corruption, it's data deletion. So, you know, the machine learning does get updated, but it really doesn't have an impact in terms of how the data is affected. By updating the machine learning, it does add the new ransomware extensions and ransomware names into it, so it's important to keep that up to date. But the machine learning will analyze the 40 or more statistics and basically come out with a yes or no determination of whether the data has been corrupted. So if each scan or each observation that occurs, you get a result from the machine learning that says no attack or green light situation, everything looks good, green light, green light, green light. If one day you do the scan and you get a red light situation or it looks like there's an attack, that's when you know that there's been some corruption of the data. And this process repeats. So continually observations occur, new statistics are generated, and they're compared to previous statistics. So when you do get that red light situation, CyberSense has quite a bit of forensic reporting and forensic analysis tools to help you diagnose what's happened. And we will get into that next. So technical specifications here: primary storage, simple NFS crawling to index the data. You set that up on a scheduled basis, fully automated. Backup software support, Dell EMC Networker, Avamar, other common backup formats like TSM, NetBackup, Commvault as well. Hardware specs, it really depends on the data capacity, but it runs on virtual servers, either out on primary storage or inside the vaulted environment. So let's get into the forensic analysis tools. They're really reporting tools in the Index Engine CyberSense product that allow you to not only recover from an attack and replace bad files with the last good file, but also diagnose the ransomware attack and help determine what caused it. So in the CyberSense product, the machine learning output, so I mentioned earlier the red light, green light situation, so deterministic decision on if the data has been corrupted or infected. So let's assume you get a red light situation, that's what you care about. You will get an email output. If this is integrated with the cyber recovery solution from Dell EMC, this will be a dashboard that's in the product that gives you an alert. However, the alert is generated by this output here. So you can see the email output that in this case gives you a red light situation. Infection found, yes. So this needs to be monitored. And once you monitor this and see that there is an infection, there's detail that's attached to the email. So there's an email attachment as follows. So this gives you a view to some of this, all the statistics that are generated. So you can see all the statistics here. You can see, change in file count. You can see change in entropy. You can see change in file sizes. So all sorts of things that compare different statistics, different observations of the files. So again, it's more than 40 statistics that are generated that analyze how data changes. Again, entropy, similarity, deletions, creations, file corruption, file type risk mismatch, files that contain common ransomware extensions. All that information is generated on a daily basis or whenever you scan the data and create an observation. And then the statistics are compared from the one observation to the next. At the bottom of this report here is the specific attack vector. So here you see the infection found is attack vector number 4. So this is the output from CyberSense. This is delivered into your inbox, or if it's a Dell EMC cyber recovery deployment, into your dashboard that tells you that something looks suspicious about the data from the previous observation. So what does attack vector number 4 mean? So there is tools that are provided with the CyberSense product that'll tell you the type of attack. So attack number 4, or attack vector 4, is really defined as strong encryption with no new known extensions. So for the cyber engineers out there, you'll know exactly what type of ransomware this was based on the description. There's detailed description there. There's 23 basic types of attacks that are listed here, and that includes encryption. So attack vector 4 there, which is file encryption and changing of extensions and so on. That's one of the most common attack vectors. Entropy change, deletions, creations, file extension change. So these types of attacks are mapped to Index Engine's queries. So in this case, you can see this is either encryption of files or database pages. Index Engine provides query tools that you can use those queries and say, show me the files that have become encrypted, or show me files that have extension mismatch, show me files that have become corrupted, show me files that had deletion or mass deletion, and so on. So these queries, once they're created and run, will give you a specific listing of the files that are suspect of being corrupt and attacked. So this gets you down to that granular detail. So we're doing a forensic analysis here of the corruption, saying this is a list of files that we need to be worried about, which is great because you can use backup software to replace them. You can know exactly where they are on the network. But beyond that, we can go further. We can connect to the event logs. So right now, CyberSense supports the Windows event logs, EVTs. And then you can take that listing of files that have been corrupt, and you can find the last user that modified those files. So if you do a query and say, here's the files that are corrupt, show me the user that made those modifications. You can look for patterns. So if there were 500 files that were encrypted or deleted, you can scan through or report on the event logs and say who made those deletions or who made those modifications or encryption. And if it turns out it was all done by John Doe, the same user, then obviously that's where the malware is running on that, from that user. You need to shut that user down look at that user's computer and diagnose that. An enhancement that's coming out very quickly is that you can also have the ability to identify the application that made those modifications. So again, if you had 100 files that were encrypted, you found that it was done by John Doe, you severed John Doe from the network and isolated John Doe from the network to stop further attacks from happening. And then you saw from the event logs is that the application that caused that was xyz.loki, for example, and the full path and location of that, that's where your malware is located. So you have the potential here to detect and find the malware as well. So the full forensic suite here allows you to do diagnosis to help recover and replace those files, but also to do an analysis and to help detect potentially detect the location of malware. So now that you've detected the files that had problems, Index Engines has the ability to restore from last good backup. So if you are analyzing backup images, we can find that the last observation, so the observation yesterday was a green light or a good situation for that to clean backup. So let's take those files and replace them from that backup. So Index Engines has the ability to index those backups and extract individual files, last good files, and replace them without using the backup software. Also, if those files are in the backup format, the corrupt files could be extracted for further cyber analysis as well. So that's the general introduction. Again, the benefits are that CyberSense can provide support to detect indicators of compromise, looking for attacks that include encryption, ransomware destruction, slow corruption. If you're indexing or creating using CyberSense on backup images, the beauty of that is it's not rehydrating the data and won't allow the malware to further create destruction. And as CyberSense looks at additional observations of the data, it gets smarter and smarter. So each observation and subsequent pass, as it compares data to previous observations, CyberSense gets smarter and gets up to 99% accuracy in detecting corruption. Additionally, the forensic tools allow you to help recover, to minimize business interruption, and to diagnose the attack vector. So CyberSense can run on your network files servers as well as your primary backup environment, but it could also run within the Dell EMC Cyber Recovery Vault. If you're looking for that solution, this is the workflow for Dell EMC Cyber Recovery and CyberSense. If you see in this diagram, you've got your production data domain environment, your file shares and data environment. Within the vault, you've got your vault data domain, your management host, which runs the cyber recovery application, Index Engine servers, which are virtual servers to do indexing that can be stacked up depending on how much data you have. So the workflow is pretty standard. A lot of this is managed by the cyber recovery solution, whereas production backup occurs to production data domain as normal. The production data domain notifies the vault data domain to open the data domain, the vault interface, which is opened. The replication port is open. The backup is replicated into the vault data domain. The interface is disabled, and the cyber recovery vault is isolated from the network. At that point, retention lock is applied. So at that point, the cyber recovery product, everything you see in there in the grayish blue arrows is all done by cyber recovery. The CyberSense product from Index Engines is fully integrated and ready to go. But at this point here, step 6A is that the cyber recovery product notifies CyberSense that the replication is complete and retention lock has been applied. At that point, CyberSense indexes the vault data domain backup image, creates the analytics, applies the machine learning, and then reports the results out to the cyber recovery dashboard. Also, cyber recovery or CyberSense has the ability to extract from the backup any suspect files for further inspection for analysis. So if there's a need for certain files that have been infected or corrupted to be extracted, a lot of organizations have cyber analysts and cyber engineers that would like to get those files to do further analysis on them, and so on. Simple implementation. The CyberSense product is a Docker that just gets implemented as part of the cyber recovery product. everything integrated, everything set to go, and CyberSense is an alert that sits in the cyber recovery dashboard. So that's it. That's the introduction for the CyberSense product. If you do have questions, feel free to contact us there. Our email address is there, info@indexengines. We do have a detailed technical white paper. Feel free to request that, and we look forward to answering your questions and supporting your activity in the future. Thanks, and have a good day.